Hello again, everybody. It's Chuck Bowen at Lawn and Landscape Magazine. I want to thank you again for taking the time to sit down for today's presentation, Lawnmower Blades 101. Today we have presenting for us Gerd Bauer II, the VP and owner of Magna-Matic, a company that makes very high-end, very nice blade sharpening tools. And he's going to talk about the importance of proper lawnmower blade maintenance and why it is such an important part, not just of your service, providing quality cuts and good service to your customers, but also such an important part of your operation. And it's something that can really improve the efficiency and productivity of your mowing crews and your entire business. Before we get started, I want to just go over a couple of housekeeping items. Today's session is being recorded. We will send you a link to a recording of the presentation as well as a link to Gerd's slides about a week from today. So you can look for that in your email next week. If you have any questions during the presentation, we are going to do a Q&A after Gerd's presentation. There's a little chat widget down there on the right-hand side of your screen. If any questions you have, just type those in there. Those will come right to me, and I will toss those to Gerd after he's finished with his presentation. So we are ready to go, Gerd. I am going to hand things over to you, and you can get started.
Excellent. Sounds good. We'll do another little mic check. So hopefully everything sounds good here.
Sounds great.
And, excellent. So we'll get started here with all this exciting stuff we've got for today. As Chuck said, I'm one of the ownership of Magna-Matic Corporation, and just to give you guys a little background, we are a family-owned company, and I am the third-generation ownership of Magna-Matic. And so we'll start some of this with a little bit of history about the company because it ties into the whole industry. And here's a nice old picture of a trade show. That's actually my grandfather and grandmother at a trade show demonstrating the balancer. And so where we kind of come from is in the 1950s is really the rise or where the engine-powered push mower become popular among homeowners, where it really becomes a mass-produced item. And in that happening, Briggs & Stratton at the time was one of the largest engine manufacturers of powered lawnmowers. Now, they started to experience warranty issues, and my grandfather, A.J. Carls, he was a mower and implement dealer at the time, recognized the problem, and that was that the blades were out of balance. And the blade on a push mower especially is the flywheel of the engine, so you have all this vibration being directly imparted to the crankshaft bearings, and which will eventually over time tear apart the engine itself, and that's what was happening. And then in the late 50s, we design and market the lawnmower, the Magna-Matic blade balancer, which is originally patented by A.J. Carls, and really becomes the standard in the industry to the point that Briggs & Stratton specs that unit as the only tool to use for blade balancing to prevent these warranty problems. Moving on forward, in the 80s, we start designing sharpeners and getting into that whole realm of things. And really the reason we did that is because at the time, and still even continues today, there aren't other manufacturers really designing a machine around the needs of a lawnmower blade. Instead, most of the industry has taken things that already exist, such as bench grinders, belt sanders, other things like that, and modifying them into the use for a sharpener. So, and also we're addressing things of like not burning the blade, keeping the correct angle and things like that, and really providing full service systems for not only sharpening, but balancing, sharpening, and the whole gamut that we'll go through. In the 90s, we design and patent the first mulching blade sharpener that can actually keep the same angle and cutting edge along the whole length of curved and bent cutting edges. And in the 2000s, we start developing cleaning machines, and a little tidbit in the webinar today is this summer we'll be releasing a very nice high-end dust collection or air cleaning system, again focusing on the health and safety aspect of grinding and sharpening lawnmower blades. And that's also something to mention. We've always, with all of our products, have designed to ANSI and OSHA safety standards to the industrial level, which is a little bit different in the industry where a lot of that hasn't always been looked at because, of course, we want that operator safety to be there. So just a little interjection here of kind of the model lineup. Of course, the flagship balancer. The red model is kind of our landscaper unit. The yellow unit is the one that can do mulching blades and conventional. The blue unit, the 12008, is our cleaning machine, and then showing kind of the workstations. So that's it for that kind of information. And the next transition here is really talking about lawnmower blade service and how did it become really so unimportant, or why is it overlooked today? And what you have from the history is really from the 1950s up through the 1990s. Every dealer is a servicing dealer. You know, the small engine mechanic is a commonplace thing. Manufacturers and dealers have closer relationships. The industry, of course, isn't as big, so you always get that. And of course, as an industry grows, you get less contact between the manufacturer and the end user and the dealer, so on and so forth. And then we have some things happening really in the 90s where, you know, not only recession and things like that, but there's a total shift in how products are sold. Big box stores come to be, and you get a new situation that equipment is being sold without service. And of course, you know, the internet doesn't help that situation either. So when you have equipment being sold without service, a lot of things happen. You know, the customer no longer is getting education from the dealer. There's less mechanic education. You know, also through this time, manufacturing costs shift, and inflation and many other factors make work that mechanics are doing become more of a part replacement situation rather than the rebuilding as it once was. And today, not too much engine rebuilding is being done on small engines. It becomes a little bit more of like a replacement situation. So again, that kind of watering, you could say watering down of service. The other thing that big box stores and this whole change do is even create a little bit of dealer animosity, and you'll get things of where, you know, you'd get some dealers refusing to service models that they didn't sell, or those models or that work that came in that wasn't sold by them gets put at the end of the list. And really the customer starts getting left to fend for themselves. And you'll get a little bit of, as it goes along, dealers and manufacturers partner a little bit to kind of service those big box stores, which helps, but then that makes the dealer, from their perspective, now have to do more things to bolster their service, which is like throwing things in. And one of the first things that kind of got thrown into service is lawnmower blade service. So all of a sudden that becomes like a free bonus thing with a full mower maintenance, which really devalues lawnmower blade service and its importance. And then that's just where that comes from. And then, of course, you know, the most of the crowd here are, of course, landscapers, I assume. We have what I like to call kind of the rise of the landscaper. Through really the 90s and the 2000s, this whole industry really grew. And with all industries, they start with small operators doing a lot of their own service to get by on budgets, again, without that connection to the manufacturer, because a lot of times, depending on how the equipment was bought, there may not be that dealer help. And the rest of this whole webinar, we're really going to go into detail about, you know, and outline why the lawn blade was always important and remains important as the thing that has the most direct effect on your end product, which is a beautifully cut lawn. So now, before we use or service a lawnmower blade, we should really know how it works. And we're going to really kind of start at the beginning with this, and that is how our materials cut. In this world, in manufacturing and everything, we cut a lot of different materials. And I have a little overview here on some of the primary ways. Sawing, which is typically many teeth drawn across usually a stationary material. Shearing, which is always two blades shearing, of course, against each other, things like a reel mower or scissors. Slicing, which is typically knives, swords, where you have a fine edge drawn against the material that is usually stationary. Abrasive cutting is typically defined as a many-grain crystal point structure that cut as they are moved against the material. And lastly, we're going to talk about fly cutting, which is one that's not typically known unless you could say kind of come from a machining background. The pictures here on the slide are of what's called a shell mill. And you can see there are little insert tips, and those are what do the cutting when, let's say, in a milling machine, somebody is milling off a whole big block of steel or aluminum, such as that. And the type of cutting, the way this functions is that there are many tips or teeth cutting at a high speed and a high feed rate. And this is really the cutting type that is most in common with a lawnmower blade. So now we understand a little bit about cutting. We should know how the lawnmower blade actually cuts grass. And a lawnmower blade cuts grass with a centrifugal force like a milling machine, which we said was called fly cutting. The cutting tips of that rotary lawnmower blade do the majority of the cutting work. The interior edges that you see on blades, whether it be a curved mulching blade or a straight blade, are typically for post-treatments to reduce the chip or clipping size. Chip is typically the term for wood chip or metal chip, but with grass we're talking about clipping. So it's really, again, that post-treatment. And of course the effectiveness of those interior edges often rely on the design of the mower and the interaction of the blade design, the airflow, and the deck and the baffle designs all working together. Okay, and so that gives you a little background there on how we're cutting the grass. And so keep in mind, this whole process is probably a lot faster than you thought or maybe had appreciation for, but keep in mind the lawnmower blade has a higher tip cutting speed than almost any other cutting process in the world. And a lot of that happens because we're cutting at such large diameters. So when you compare it to things like any other machining process or any other high-speed cutting where a lot of materials are being removed in a short period of time, the lawnmower blade is almost king. It is extremely fast. And of course now, why is it so fast? Well, you've got one situation that it can be fast because of the material density. A lawn is made up of, of course, many blades of grass that have a lot of air in between them. So we can cut because we're not doing a dense material like, let's say, wood or steel. So we can actually have a really high feed rate into something that is not solid, you could say. And of course, in the same breath, we have to say it has to be a fast cutting process, because if it wasn't, we would have a problem with the work holding. Work holding is typically the term, of course, for how you would hold a piece of steel, let's say in a machining center or something of that nature. For example, a vise. What is our work holding for a lawn? It's the roots of the grass and the strength of the blade of grass holding itself up. And it's a movable object. It is not held solidly when we come to cut it. So we have to come and hit that grass with the lawnmower blade at such a speed to knock it off before it even knows what happened to it, basically, is what's happening there. Now, here's a little bit of a fun slide, even faster than you thought before you saw the last slide. Consider that a lawnmower blade running at 18,000 surface feet per minute, which is the tip speed, is approximately equivalent to a race car's wheel going 200 miles an hour. So think about that speed for a while. There aren't a lot of cars in this world that do 200. So I suppose you guys probably never thought you had much of a Bugatti Veyron lawnmower out there. So, but while that's funny and it's cute, the lawnmower is really a high-performance piece of equipment that a lot of times is overlooked because it is such a common piece of equipment in our everyday lives, as well as, of course, in your business as a landscaper. But it's really probably safe to assume that all the wheels, the tires, and every rotating part in that race car or supercar was accurately balanced and serviced before it hit the track or road. And you really need to treat your lawnmower the same way, because if you expect to get the performance that the manufacturer promised you out of it, the maintenance has to follow. So back to the blade here after we had a little fun. We'll talk a little bit about kind of the main anatomy of a lawnmower blade. And while all of this is for the most part pretty basic, the main thing I want to draw attention to is looking at the cutting tips, which are the pointed ends, and that what we're showing here, instead of saying that it's the lawnmower blade's length, we're talking about the cutting diameter. And that's an important thing to understand, because a lot of times people aren't aware that the tips actually stick out. So we're talking about a tip-to-tip diagonal dimension for what that blade the path that blade will cut. It is not a straight length as it is a rectangle. You really have to kind of break yourself of thinking of the lawnmower blade as a rectangular or a knife or a sword or something of that nature, but rather much more like a disc that is cutting with two teeth. Now, in a cutting edge, we have things called relief angles. And relief, just to define that, is to reduce pressure or stress. And a relief angle in a cutting tool is an angle that allows chip clearance and material clearance. So it basically relieves stress on the cutting edge, you could say, allowing the chip to get by. And the first relief angle that we're going to talk about is what's called the diameter relief angle. And by the number 1, you can see this is an overhead view of a lawnmower blade. And you can see here, well, hopefully you guys can see my mouse. I'm pointing here to the tip of the blade by the cutting edge. You can see how it is not a perfectly overhead square view. It's actually 1 to 2 degrees back so that not only the tip sticks out, but keep in mind, if that were totally square, in the next image here, the back portion of the lift would tear the grass on every rotation because it wouldn't be allowing the grass that was uncut to get by when the tip of the cutting tooth made the first path. So basically this green line is the grass, or the path of the grass, and if we're contacting on both corners when everything is square, this is going to be an unfavorable cut. So the next cutting edge relief angle is here for the actual cutting edge. This is typically an industry average of 30 degrees. It's what all of our sharpeners will consistently grind the lawnmower blade at, and it's needed for the chip clearance or the clippings to flow up over the lift and then either be evacuated or be circulated among the baffles to be recut. So this one is for chip clearance, and this is, of course, you could say the area where we do grinding for sharpening. Now, the last one we call the land side relief angle, which is kind of an interesting one. On the image here on the right, where you see the number 3, you can see that there's a couple degrees difference between the blade on the left. So a mower manufacturer or blade manufacturer can build this relief angle into the blade by either creating a twist or bend in the blade so that as the blade makes a rotation, the bottom of the blade isn't rubbing across the tops of the grass that you had just cut. It's, again, to allow that material clearance, in this case, where number 2 was to relieve or allow chip clearance or clipping clearance. Now, getting back to what I said, what was interesting about these two is that the one on the right is where if it would be built into the blade, but this relief angle can actually be completely flat like the blade on the left here, but the way you then achieve this relief angle is manufacturers sometimes will pitch the deck forward. Basically, the front of the deck is slightly lower than the back, so you can actually have that built into the blade, or it can be created by the design of the mower itself. That's kind of an interesting one because it can be achieved 2 different ways. Now, how does proper mower blade maintenance really benefit you? And I could make this list longer, but we went with the basic ones here. And really the primary one to focus on is that when you maintain a blade properly, you are cutting the grass rather than tearing it. And having that pointed tip, which we'll focus on more, is that cutting tooth. And when the cutting tooth is not intact, you are essentially a glorified weed whacker when you have a rounded corner at the end of the blade. And that, of course, then will keep turf greener for a longer period, because when the tip is cutting the grass and it's an actual cut rather than a tear, the blade of grass isn't frayed and it doesn't yellow and brown more quickly. Something that a lot of people don't really know where it's coming from is double cutting. Now, double cutting can, of course, just occur because someone is driving too fast over too tall of a lawn. That's naturally an issue there, too. But double cutting can also occur when blades are so worn that the tips are such a large radius, which we'll show in some following slides, that back to that anatomy picture, we're not making that full cutting edge diameter. So if the tips aren't sticking out to make the cut, your blades are in effect shorter than they ought to be, and therefore grass is being left behind, creating that need for double cutting. Of course, reducing downtime, faster forward cutting speeds when things are balanced and sharpened properly. Fuel efficiency. There have been lots of studies done that a balanced and sharpened blade can yield sometimes up to as high as 20% fuel efficiency for the mower. And of course, there's less load on mechanical components. and it's much more pleasant for an operator to run a mower that is maintained and running smoothly. Now, getting into the service side of things, after we've established everything of how the lawnmower blade works and a little history about the service, we're really trying to provide a standardized work order or directive for service, so people know what to do. Because right now, you could call it to some degree old wives' tales and folklore, the way people talk about how to service a lawnmower blade. Everybody's got a little bit different story, or how this person did it, and so on and so forth. So we're going to next go through all the steps in this flow chart, step by step, to kind of give you a full walkthrough of how this all fits together. So to begin, when we take a lawnmower blade off of the mower, the first thing we really have to determine is it worth sharpening? So is the blade worn out? And what we want to do is visually inspect the blade to see if there's enough material to justify sharpening. And a lot of times people aren't even sure of how to find that. The upper picture here with the two red lines is basically, or very generally, showing, you could say, the resharpenable life of this mower blade. And again, getting to the relief angles, when you run out of one of the relief angles or surfaces, the blade is worn out. And the one that you run out of in a lawnmower blade is the underside, because as you, of course, grind the edge back, you'll eventually hit the bend of the lift, which would then pitch the angle differently if you would grind into that. So there's your kind of answer of how do I determine if a blade is worn or if I can still resharpen it, is basically looking at the end of it like in this view. And so the lower picture, of course, is a very worn blade, and you can see we've got essentially nowhere to go before we hit the lift, because as far as we would have to grind this back to get a pointed tip again, we would be in the bend of the lift. And of course, if there's not enough material, you discard the blade. The little continued portion of the pre-cleaning inspection is to visually inspect the blade for any cracks or fractures or other extreme wear in sandy soils or anything else like that. And many blades have notched cutouts like that, and sometimes you'll get very weak points between here or cracks beginning. And basically, if you see any crack or any fracture, any terribly obvious sign of damage, immediately replace that blade, throw it away. It is not worth the risk to try and get one more sharpening or mowing out of that kind of blade. So the second step in the flowchart is cleaning. We need to clean the blade of all the vegetable material and debris. And it's not, a lot of times people think that's just for the balancing, but it's not just for the balancing. And keep in mind, cleaning can be done in a lot of different ways. Hand scrapers work, open wire wheels work. Some people soak blades overnight and then do things like that. We, of course, offer our MAG 12,000 blade cleaner, which keeps everything very clean and is able to do it quickly and safely for operators. And so then after we've cleaned it, we need to quick visually inspect the blade again for any cracks that were under that vegetable material. And that's the other thing, aside from balance, having an accurate balance, having no extra material or weight on the blade, but really to be able to see if there was something under the grease and grass clippings and everything else in the under that material, if there were cracks. So after that, if the blade is still all looking good at this point, we now need to check the straightness, if it was bent, if somebody hit a rock or something like that. And in this image that you see here, we've got two views of the MAG 1000 blade balancer from a side view, and of course normally this would be mounted on a wall or on our stand, but we've got the pictures cut out so we can focus on the blade instead. And in the first image on the left, we're having the gauge rod, as we call it, for checking the straightness in proximity of the back of the blade here. In the second picture, we will have rotated this blade 180 degrees to compare the other side of the blade to where the gauge rod was left. And we can see here that there's a deviation between these two, which then tells you that the blade was bent and the tips are no longer tracking in the same plane or in the same level. And here's a quick little general straightness tolerance guide that we provide, but also keep in mind you should still consult your either mower manufacturer if you have a blade manufacturer's tolerance requirement. And please, everybody, never try to straighten lawnmower blades. They are a hardened steel product, and you will create fractures trying to bend a blade back. And of course, as soon as you have fractures, the blade has the possibility of breaking apart during use and being propelled by the mower. So it's just simply avoid trying to rebend blades. It's not worth the cost of the blade. Now, number 4, moving into sharpening. And even before we get into sharpening, we have to understand what normal blade wear looks like. So the natural wear pattern of the blade is for the tip to become rounded after use, which I'm sure all you guys have seen. Here's a new blade, nice pointed tip, and here's a worn blade. The dashed lines show where the blade was when it was new, and then of course after numerous hours of use, you begin to develop a radius or a curved wear pattern at the end of the blade, because of course that's where steel is actually completely wearing away, and directly from use. Now, when should a mower blade be serviced? Also another hugely common question, and typically we recommend between 8 to 12 mowing hours if you're looking at the greatest quality of cut for the life of the blade. And of course, infrequent blade service will result in all these terrible things like torn grass, poor quality of cut. It ends up being a lot more sharpening and work, and it's overall a shorter blade life if you let that blade go longer. So we've got a picture or 2 pictures of blades here to show you. And just for example, let's say the blade on the left here, and again the dashed blue line is to show where the blade was when it was new. And on the left one here, we've got a very small curve or a very small radius developing after, let's say, something like 8 to 12 hours of wear. Now you can see that that's not going to take a lot of grinding to get back to a pointed tip. The blade on the right, however, you can see here again the dashed blue line was where it was when it was new. Let's say this blade was out there for 20, 30 hours or longer. The larger this radius gets, or basically the longer you use a blade past that kind of 12-hour mark, you will have to remove exponentially more steel from that blade to achieve a tip again, which just effectively wears out the blade sooner, and you cut for more hours in a poor condition than you otherwise would have if you'd be switching the blade out more often. So overall, again, it really speaks to the efficiency of frequent service, and that can be argued for almost anything. Frequent service will always be more efficient and consistent. So moving into actually sharpening a lawnmower blade, and here's another kind of fun slide, how not to sharpen a lawnmower blade. And of course, this is one of those wonderful internet pictures. It was easy to find. And we've got a gentleman here, of course, standing on a lawnmower blade using an angle grinder. And things to be mentioned about angle grinders and bench grinders and all other kinds of freehand methods, belt sanders, all kinds of stuff, is that they are not lawnmower blade sharpeners. The lawnmower blade has some specific dimensional requirements that you're trying to recreate, and these freehand methods where you're determining what the angle is by just how you hold the cutting tool or how you're holding the blade are very inconsistent. And even while you might be able to get a terribly sharp razor edge with a side grinder or angle grinder like in this picture, it is intensely difficult to try and push the cutting edge back to get a pointed tip to emerge. What ends up happening is people slip on that rounded corner and basically just make the rounded corner worse and worse, effectively, just trashing the lawnmower blade really for its life. And a couple other things to mention about this picture while we have it up here is the operator's not wearing any gloves. There's no long pants, no long sleeves. It's unsafe work holding. And if you can even tell here, I think the gentleman's using a bucket, a 5-gallon bucket here that at one time had something flammable in it. So that doesn't speak to safety as well. So now we'll give you the opposite side of it. how to sharpen a lawnmower blade safely. This is a picture of us demonstrating at the GIE Expo, and if you guys ever get a chance to go see that expo, it's fantastic because manufacturers are actually there, so it's a wonderful show. And just for fun, I'm the guy on the left there, so you get a little face with the voice. And as we're standing here, things to mention, of course, we're wearing safety glasses, gloves, long pants, long sleeves. And while you see us not wearing any respirators, we have our sharpeners hooked up to air cleaners or a dust collection type of system for demonstration at the show. And you'll also notice we're not wearing hearing protection, but something to keep in mind. Here at the show, we're doing typically shorter demonstrations and talking to people most of the time, so we don't have earplugs in while we're at the show. However, if you are grinding for extended periods, always do wear hearing protection. Now, what does correct re-sharpening look like on the blade? And the definition of that, too, is re-sharpening of a blade, again, is to correctly regrind the cutting edge back to create that pointed tip. And, of course, doing that will yield these positive benefits. Now, what that looks like in this picture is, again, we're going to have that blue dashed line is signifying where the blade was when it was new, basically this overhead view of the lawnmower blade. And then the red dashed line was that significant wear we saw, where we had our big rounded corner from wear. And then now this hashed or shaded area, which is the new cutting edge, we've got a pointed tip again. And that's, again, really what you want to see, because dimensionally you're creating that geometry that the new blade had. And if you're not, you don't have that cutting tooth. Now, speaking about the angle and grinding of the angle, it's very important that you create a consistent angle because it helps your efficiency and also the overall life of the blade. When you're sharpening at inconsistent angles, you're just prematurely going to shorten the life of that total blade. And that's because, of course, here we can see in the upper picture, we've got all these different angles going on, and we're going to get fewer sharpenings if we're constantly changing the angle than if we would always keep the same angle along the length of the cutting edge. Now, the wear pattern also has to be noted over the life and how you deal with the blade over its life. And the first image shows the blade that has been sharpened many times, and the tapered shape in this overhead view is the natural wear pattern, and as you service it over its life. And it's the safest way to really retain that blade strength, because here we can see we've got in the distance here, if you can see where my mouse is pointing, we've got a much more, a larger thickness between the shape of the blade than in the second picture, where we're showing kind of this red fracture crack here. And it's very important to note that there's no benefit to pushing back the whole edge like in that second picture. You could say parallel or square to the outer shape of the blade. This is not, keep in mind, again, because the lawnmower blade is not sweeping along the grass, sliding its edge along the grass like it were a knife. Instead, it's cutting with that extremely high speed and knocking it off. The initial cut is with the tip. And so you can considerably save time and grinding wheel and just overall efficiency of doing the job when you follow the pattern of the top picture. And of course, you can see by the dashed outlines of where the blade was when it was new, we've got way more steel being removed on that second image, which really is not providing any benefit. Two other little things to mention while we got these pictures up. A lot of times people ask about nicks in the blade from damage and sticks and rocks and things like that. Typically, we like to recommend that if the nick is not within the first 2 inches from the tip inward, it's really not that critical. If it's further in the interior of the edge, you could leave those nicks. You can grind them out. That's kind of your choice. But if they're in that first 1 to 2 inches, then they ought to be removed. And also here, another thing to mention is never weld blades. Again, they're a hardened product. They're hardened steel, and if you weld blades, you're imparting a lot more heat. Sometimes people think they can weld more material on the cutting edge to get more life out of it or weld a fracture. You don't want to do that because, of course, you're changing the hardness of the blade and can also create other unsafe conditions and fractures when you're welding on a blade. So moving into balancing, the process of balancing a lawnmower blade horizontally is to bring the mass center and the rotation center closer together through counterweighting by removing material from the cutting edge. Now, while that sounds like it came right out of a physics textbook, I'm sorry to say balance is a pretty important physics subject, you could say, and so it is a little complicated, but we'll break it down here. So the rotation center. This is the center of the blade's rotary motion, and here with the black arrow we're pointing right to the center, and that is where the blade spins upon, because keep in mind, while it looks like a rectangle, when it's in motion, this part is a disc. The mass center, or sometimes called center of mass, is the middle point where all the weight is concentrated in the blade. And this circular symbol is what you would see in physics textbooks and in science matter information, how they show the center of mass. Now, static unbalance, when a blade is out of balance or has an unbalanced condition, is when the mass center and rotation center are not in the same location. Like in this picture, we've got the mass center way over here on the right, and it's nowhere near the rotation center. So the right side of this blade is heavier than the left side. So what does static balance look like then? Static balance is when, of course, the mass center and the rotation center are in the same location. And here we've got that mass center symbol right smack dab in the middle of the rotation center. And so this blade is in balance. The right half and left half are of equal weight. And tying into exactly what we did before with how not to sharpen a blade, this is how not to balance a blade. Oftentimes, everybody has thought that just hanging it on a nail in the wall is going to do the job, but you're not measuring from the rotation center. So we've got a major problem that if we're hanging at the top of the hole, we're actually throwing off the whole situation of the balance, potentially doing more harm than good, or sometimes not seeing any reading at all when this is hung on a nail. And of course, the same problem is plagued by the little tabletop hardware cone that everybody's, I'm sure, seen. Because the steps are never the same size as the mounting hole, you can never really be in the rotation center either. So again, if you can't consistently measure from the rotation center, any reading you get is going to be completely inconsistent. And while there are a lot of DIY YouTubers out there making homemade balancers out of either bearings or different thicker bolts and things like that, they all have the same problem. They might be a little bit closer to the rotation center, but they're not in the rotation center, and so therefore they're all inconsistent and really not reliable, because you can't have a measuring instrument that's not reliable. So how to balance a blade, and again, this has been the standard since the late 50s, our product, and of course it's very simple in that we locate the rotation center with the cone, and then in the lower two pictures you can see we have a magnetic chuck. That's the dark circle or the rings that you see around the cone that is pulled forward with your fingers, contacts the blade, and then the whole unit is mounted on instrument bearings and allows the blade to rotate. So when we're checking horizontal balance, we're dealing with gravity, and gravity will cause a blade with static unbalance to move or to rotate. So here in the picture A, we can see we've got this mass center over here, and again, it's not by the rotation center, it's off to the right again, and the force of gravity is going to want to pull that blade downward, which is going to force it to rotate on the balancer, and then it will basically look like picture B, where again, the mass center is being pulled down by the force of gravity, and that, of course, we have got a little picture here with the clock showing that motion. Now, with the balancer, we have to understand blade unbalance acceleration in this process. So a lighter blade will require less time to show it's unbalanced than a heavier blade. And really, the bold bullet points are the key information. A lot of times people think, oh, I don't want to balance a blade because it's going to take so long. But part of the reason why we make such an extremely accurate instrument is so you get fast readings with our unit. And basically, if a blade moves towards 6 o'clock, within 3 seconds, you know that blade has a severe unbalanced condition and needs to be corrected. But if that blade moves 8 seconds or slower towards 6 o'clock, or barely even moves, that blade is usable back on the mower again. So you're getting an extremely quick reading. It's not a time-consuming process to balance a blade, as many times people think, where they think they might have to wait till the blade settles out to some position, but that's not the case. You're seeing the out of balance condition in the movement of the blade and its acceleration or speed. Horizontal unbalanced correction is essentially that material needs to be ground from the cutting edge of the heavy side. And when you're removing that material, we recommend that you don't do it near the tip, because we had just sharpened the tips and got them dimensionally correct, and because we know that land side is our limiting factor for the life of the blade, we want to grind as little as we absolutely have to out near the tip. So use the interior cutting edges when you're cleaning those up and making those sharp again as the place to correct the balance condition. It just gives you an overall longer life to the blade. And now after you remove some material, you'll have to recheck it on the balancer, and you may have to repeat the steps once or twice to see if there is still a condition after you've ground. But of course, with experience, when people see that speed, they know the feeling of, okay, that takes me 1 or 2 passes on that blade, and I know that blade will be in shape again. The last step of the total flow chart is to either package or put the blade away, basically for storage. But while that is more on the servicing dealer side of dealing with the blade, for landscapers, I like to talk about a little bit, or a blade program. Because if you don't really have an organized program, you should really consider one. And a lot of times what we recommend is that you have multiple sets of blades per mower, sometimes either for a daily basis or every other day, depending on the mowing hours you do within a day, because of course there's travel time and things like that. You can kind of use machine hours, the machine hour gauge on the mower as a rough guide. But if you're doing that where, let's say, similar to NASCAR or race car type of pit service, and just swapping those blades out on a daily basis and getting back out to the job, rather than having someone take the blades off, service them, put them back on, and then get out to mowing, have those blades ready, and then productionize all the sharpening at one time to really increase not only the efficiency of the crews getting out to the job, but also to increase the shop efficiency of the sharpening being done. Because of course, if you're doing all the blades at one time, you're going to gain those efficiencies there. Now, in conclusion, I'd really like to hit home again that the condition of the rotary lawnmower blade is extremely important to achieve a quality cut lawn. Therefore, its maintenance is critically important to repeatedly produce a quality cut lawn. And again, I just keep hitting it, but it's consistency and efficiency. If you don't have the machinery or equipment or measuring devices or instruments to be able to consistently do the job, you can't expect to gain any of the efficiency and benefits of that job. So really, that is what we want to hit home, and really think about the consistency of how things are being done, and then therefore the efficiency that they'll yield for you, which all really in the end ends up as savings of costs to you. So lastly, thank you guys very much for taking the time out of your busy schedules to allow me to hopefully provide a little bit of insight into the methods and benefits of modern and proper lawnmower blade service. And thank you guys, the Lawn and Landscape, for the opportunity to even do this webinar. It was kind of through them that we even found out about the opportunity to do something like this and reach out to people. And if I haven't gone on too long, we can certainly take some questions.
Great. Well, Gerd, thank you so much for putting that together and sharing all that information. I think you made a lot of really good points about just how important this topic can be for the average contractor. I, for one, did not know how fast the tip of a lawnmower blade was traveling, and I think just very fascinating stuff. I think one of the main questions we've been receiving during your presentation is a lot of questions about how to increase the longevity of the blades that guys are using. Do you have any insight on that? beyond just keeping them in good shape, but how can they make these blades last as long as possible?
The main factors that are going to deal with that, of course, is sadly the types of properties that they're mowing. You know, the cleaner and nicer the property and the less things they're hitting with blades will of course yield to that. That's you know, relatively straightforward. But as far as what they can do, it's really kind of just a very straightforward point of the blades need to be maintained as frequently as possible, because it's not only making the blade last longer, but the blade lasting as long as possible, operating at its highest level of quality. You know, the blade, you could run a blade for hours and hours and hours and never sharpen it, never balance it, and just run it until, you know, there's almost nothing there. And you'd get a hugely long life out of it, but the quality that it produces would be, of course, terrible. So it's really kind of maximizing the quality that the blade is giving you for its life. And really that is through the proper maintenance and maintaining those when they're grinding, because you can lose so much material with improper grinding.
Right, right. Well, and I thought your point on having sort of a blade program really makes a lot of sense for all the contractors out there listening. You know, being able to have just a stock ready of sharp blades that you can change out, kind of batch it all at once. Really, you know, I know everybody out there can notice the difference between, you know, a freshly sharpened blade on there and then one that's been running for a couple weeks or a couple days. One question we're getting is, you know, if you're running a big walk behind or a zero turn, you've got multiple blades running all at once.
Yep.
Are those like tires? You know, do you have to replace those all at once, or can those kind of be treated as independent parts?
They can be treated as independent parts if they're being balanced at the same time and sharpened at the same time. Or I should say that if they're being consistently balanced and sharpened, blades can be interchangeable. They don't have to be sets. It comes again down to the consistency of the service and the tools they're using, that each blade is essentially the same, because again, if they've got the tips ground correctly on all those blades, they're going to all be at the correct diameter, even if one is new and one is worn. And of course, if they're all in balance, they're all in balance. You've made them equal, you could say, through service.
I see. So once they're balanced and sharp correctly, you know, those blades they could be moved around to whatever machine they could fit on. They're not unique to that position.
Correct.
Got it. Well, Gerd, thank you so much for taking the time today. You know, I learned a lot. I think all of our attendees really learned a lot. Any final thoughts for the folks on the line here?
You know, it's just hammer it home. I spend a lot of my day talking to people, just trying to convince them to sharpen more frequently, and it's you could say possibly the greatest battle we have, because you know, it's not just as a promotion of our products, but it's really to gain all this efficiency, because honestly, have one of our sharpeners, and I tell you to sharpen more frequently, you're going to use less grinding wheels and things like that. You know, you could say that's to my detriment, but it's to the huge benefit of the contractor to really get those service operations consistent all the time, and really that's going to give you the proper efficiency. And when you're looking towards equipment to do, really be critical of how they're addressing the angle. Is the machine safe for your employees? And what are you actually, you know, look at the criteria of it, and also what kind of support that you can get from it. And, you know, not to sound too much like a plug, but I will let you guys all know that we are one of the last manufacturers making this type of equipment in the United States. We source American-made motors. The grinding wheels are made in the United States, and then, of course, all the parts that we manufacture in the machine are made here in Wisconsin. We're located a little north of Milwaukee. And because we sell in kind of a factory direct situation, you have a direct line to us all the time, and that's what I was talking about too. Because again, the way industries grow and things like that, we're in a situation, and because this is such a niche product, we're able to remain in really good contact and provide this kind of educational information. And we have training information and training programs, and we're continually putting out more videos on how to use the equipment and even service our own machines and things like that, to really have that you could say industry partner rather than a catalog that sold you a sharpener.
Right.
We are trying to actually provide that information and have that contact. We want customers to call us, not just, here's a machine, we'll see you later.
Right. Well, I think too, this is a really important component on increasing the longevity, not just of your blades, but of your equipment as a whole, and also, for the average contractor out there, a great way to differentiate himself and his company from his competition. Customers see a lot of that quality and the sharpness of how a property looks. That's the first thing they're going to notice. So
exactly.
that kind of edge that you can give yourself over your competition, doing something as straightforward as this, I think a lot of guys should be doing that. So Gerd, thank you again for taking the time, and everybody else out there, good luck. Thanks a lot.
Thank you.